Welcome to myprojectbazaar.com. Now we are going to discuss about our product. Title is partially repeated SC-LDPC codes for multiple access channel. Let me see our product abstract. The partially repeated SC-LDPC code can be close the MAC capacity. The experimental results show that the partially repeated SC-LDPC codes have better performance. The graph extends and then parallelly connect the SC-LDPC codes for the MAC. Now we consider the coding complexity. Is well known the decoding complexity of SC-LDPC code is mainly determined by the check node decoding. Compared with the original SC-LDPC code, decoding of our process coding of only increased by the LLR combination of each decoding iteration. In contrast, the previous code for the introduce a new check code achieve the low rate. Their complexity increase much more than ours. A simple partial repeated coupled low density partial check code is proposed for a multiple access channel with a large number of users. This code is constructed by selecting part of bits of SC-LDPC code is repeated. Since the decoding increment is only the log out the ratio combinations. The compared with the original SC-LDPC code, the decoding complexity scarcely increases. Now the LLR combination of effective use overcome the multi-users interference, the optimization of the ratio of code bits for repetitions, the coding of decoder threshold of the partial process. In our process, idea for using the repetitions construct a low rate code is also now used. The consider the irregular array code, which need very complex degree optimization process to design the code for the different number of users and noise level. We use SC-LDPC code which has been used the universal most channels. Moreover, another difference of the work most prevents process of a MAC process. The reason of the during the iteration decoding process, labelty of message at two ends with the low degree check nodes are higher than the middle positions. The advantage of a presso, the independent interlevers the each position so that reliable message for the position of the convergence. Let we see our process flow diagram. In our process we have given the LDPC process for the main objective for the error checking method and correction the method. We given the input bits whatever we like the bit for 8-bit and 16-bit and 32-bit maximum 64 8 available from that depend on the RAM process for CPU. After we select some inputs, we get the input bits. We go into the arrange the bits. This arrangement of words which need to be error checking, and the bits are arranged the bit by bit to shift register from this parallel bit to error checking method. After arranging bits completed, we go to the check parity method. In this process, we find the parity bit as a word to find error bits. There are n number of bits we have given. After the n divided by 4 process the XOR key to get the parity bit from the parallel to shift register. These parity bits are considered as a parity word as feed these majority logic circuits. After completing this process, we go to the parity bits. In this process, we check the error bit from the parity word. In this process, we first find the maximum likelihood bit range of the neighboring bits, then from the decoding using the MLD algorithm. The MLD algorithm bit check the process. We correct the error bit by checking the lost bit from shift register and bit from the majority logic circuits. In this error correction stage, we use XOR gate that changes error bits if there was change in bit. The compare bits the lost bit from the shift resistor and bit from the majority logic circuit, and finally correct the error bit. After we go into the XOR operations, in the XOR operation we have completed the architecture designing in the using the mux and RAM process. After giving the input, we check the which giving the input process we have using the store the which position is stored in the RAM positions. Let we see our process running processor. In our process we have completed the coding for the LDPC code this folder. After opening the process, we have designed the process in the Xilinx 1452 version. Just we have designed the SI behavioral part of the program process. Now I'm going to the simulate the process. Here the simulation, click the implementation result. So now we are going to first simulate the process, the coding. So we click the process and the simulate behavioral model method. So automatically open the simulator for ICM process. We have give the input for bitwise and get the output for the. So we have designing the clock and reset enable process and the input data for 15 in bit. So the SR output for the get the process after the shift resistor and the which parity we have checking the level for the LDPC code for. So now on the checking the process for the clock. So give the force clock. So leading edge value for 0 and trailing edge value 1, period for 1000 ns. After the reset for going to 1 and enable also either force correction for 1. So just and then we going to give the input for the 11100. After completing the process, just we run the process, the SR output we get it and the shift resistor also get it. So now we need a parity check. So I am going to the write the process for zeros. So shifting process. So we give the input and we just make the shifting process. At the same time 1001 the parity checking level. After we give the clock variation, the shifting process, the one by one for bit by bit we need shifting the process. After the process we just zoom the we split the process, just we go through the, so give the input for the 000 and the parity also 0, and then get the input for the 111100001110 process. We get the shift resistor. After we give the enable and the clock also one shifted, we process the 10001 process is automatically shifted. This process will be the checking the LDPC process. After completing this process, this is a simulating process, we go into the implementation result. So in the implementation result, it is for the RTL schematic diagram and technology diagram and the device utilization process we get from here. So this is the synthesis report you just run, and same time implementation result will be run automatically. Open the view RTL schematic diagram and view technology schematic diagram and then implementation result. After this process also we have running the process, we get the result from there. After completing the process, we are just viewing the process for the implementation for result for the synthesis report. And the same time we new device utilization summary. Oh, this is our process. What we have using the flip-flop level and LEDs levels and the flip-flop pairs used and LEDs pairs input output bonded levels. This is the maximum we have what we have using the process. This process. After we go into the view the schematic back enable reset. This is output for the same way with the design process. So this is our schematic diagram for our process. Thank you viewing our website.